All right, here we go, everyone. Our objective for today, I can solve rational equation. Let's read together. 1, 2, 3. I can solve rational equations. So, yes, we already finished rational expressions, right? We had fun by simplifying, by multiplying, dividing, and then we added and subtracted. Remember those? Yes. So, rational equations. We need a Fourier model. It says, rational equations are an equation that contains one or more rational expressions. Rational equations, an equation that contains one or more rational expressions. Examples. 6 over g plus 4 equals 2. 2x minus 14 over x squared minus 15x equals 1. Of course. 2x plus 6 over x squared plus 5x plus 6 equals 1 over x plus 3. These are all examples. You should be almost done copying that. And then we write the non-examples. There they are. And copy those. I'll give you about a minute. Go. All right, here we go, guys. It says rational equation. Definition. An equation that contains one or more rational expressions. So here are examples. Here's an equation. Does it have at least one rational expression? Yes, here it is. Another equation, does it have at least one rational expression? Yeah, right there. Here's an equation. Here's a rational expression, and here's another rational expression, so therefore it's a rational equation. Let's look at the non-examples. So this is a non-example compared to this one over here. This is a non-example compared to some of these over here, and this is a non-example. Think about it. Why, if these are not examples, why are these non-examples? Think about it. All right, discuss it with your neighbors, please. Why are these non-examples? So once again, one thing that we notice is that these are all equations. That's why that's our first bullet here, equation. And all of these have at least one rational expression. So these two things have to be met in order for it to be a rational equation. And by the way, we already solved some of these at the beginning of the year. Well, towards the beginning of the year. However, we used rational equations, but involving only numbers. Today we're going to be looking at some examples that involve polynomials. Yay, polynomials. So with that said, underneath that, write these steps down. It's only two simple steps. Steps. Step 1, when the rational equation is a proportion, cross multiply and solve. When the rational equation is a proportion, cross multiply and solve. When the rational equation is a proportion, cross multiply and solve. When the rational equation is a proportion, cross multiply and solve. When the rational equation is a proportion, cross multiply and solve. When the rational equation is a proportion, cross multiply and solve. When the rational equation is a proportion, cross multiply and solve. That's step 1. However, step 2 says, when the rational equation is not a proportion, we multiply by the LCD, simplify, and solve. When the rational equation is not a proportion, multiply the LCD, simplify, and solve. Copy that, please. Okay, everybody got this down? Yeah. All right, so things to pay attention to. For the first part, if the rational equation is a proportion, so that we remember what a proportion is when a fraction equals another fraction. Remember those? That's the only time we cross multiply. However, if it's not one fraction equal to another fraction, that's when we need to find the LCD, simplify, and solve. So let's start with the first part. Here we go. Copy example number 1. Example 1. It says, solve 5 over x minus 2 equals 3 over x. solve 5 over x minus 2 equals 3 over x, and it says check your answer. So now, we already did these before. I already kind of like introduced you to these some time back so that you were ready for this lesson. And let me show you. Let me refresh your memory. Let's do this together. Is it a fraction equal to another fraction? Yeah, so it's a proportion. So we're going to cross multiply. Let's see. 3 times these two terms. So what do we have? 3x minus 6. And we have equals. And we cross multiply the others. 5 times x, that's 5x. Are we there so far? To solve, we start by getting all variables to one side. Is that correct? We start with the smallest one, which is the 3x, so we subtract 3x. Subtract 3x to each side of the equation. We're left with negative 6 equals 2x. And our last step is what? Divide by 2, divide by 2. There's a giant 1. That's x equals negative 3. Remember these? Yeah, right? That at first everybody was freaking out on me, but then after we did it, it was a decent one. So check this out. This is the easy part. So that's why I'm getting you guys ready. So here we go. So any questions with this? But we need to check. And how do we check? We're going to rewrite this over here. 5 over parentheses minus 2 equals 3 over parentheses, because we're going to substitute the value for x. What is x? Negative 3 and negative 3. Let me do this fraction first. What is negative 3 and negative 2? It's not multiplying. Negative 5. So this is 5 over negative 5. What is that? Negative 1. Let's simplify this one. What is 3 divided by negative 3? So did it work? Yes. So therefore, this is our solution. Agree with me? Okay. Let's do another one. See if you can do this one by yourself. Same process. Example 1. 8. Copy that, please. It says, solve 1 over n equals 3 over n plus 4. 1 over n equals 3 over n plus 4. Do we have a fraction equal to another fraction? Yes. So therefore, you know what to do from there. Go, and I'll give you about 30 seconds. Go. All right, let's see. So we cross multiply. We got 3n equals to n plus 4. From there we subtract n to each side. We're left with 2n equals 4. And at the end we divide by 2, divide by 2, n equals 2. Hands if you got that. Okay. No, like I said, when you get started, as long as you cross multiply, you set it up. It doesn't matter if you put the 3n over here and the n plus 4 over here. As long as you do one thing to one side and to the other after that. Okay? To check, you wrote 1 over open parentheses equals 3 over open parentheses plus 4. But instead of the parentheses, we write a 2. This is 1/2 equals, this is 3 over 2 plus 4, that's 6. And what is 3 over 6? Is 1/2 equal to 1/2? Yes. So this is a solution. Okay? So far so good? All right, and let's do one more just to get enough practice. Copy this down, please. All right, number 1b. Solve 4 over h plus 1 equals 2 over h. 4 over h plus 1 equals 2 over h. You got 20 seconds. Go. All right, let's see what we got. Cross multiply, we get 2h plus 2 equals 4h. Hands if you got that. So if you got that, after that it should be a piece of cake. So therefore you subtracted 2h, subtract 2h. We got 2 equals 2h, divide by 2, divide by 2, h equals 1. To check, let's see. 4 over parentheses plus 1 equals 2 over parentheses. And instead of the parentheses, it's 1 and 1. Let's see. This is 4 over 2. What is 4 divided by 2? 2. What is 2 divided by 1? 2. It does check off. Okay? No. Whatever it gives you, and if it equals that, then yes. Okay? Are we there so far? That's enough practice with the easy ones. So let's get started with the interesting ones. Yes? All right, here we go. Those were the ones where we had a proportion. Now let's find out what we do with the ones that are not a proportion. Copy this down. Example number 2A. Example 2A. It says, solve the equation and check your answer. 4 over x minus 3 over x squared equals 1. 4 over x equals 3 over x squared equals 1. All right. Everybody copy that already? Okay, pens down really quick. I'm going to go over this example. This is going to be the one that's going to take us to the next one that hopefully by this one it will get you clear. So here we go. I'm going to look at the denominators. Since we have a fraction here, we need to get rid of the denominators. Now, everybody look up, please. I'm going to write an equation here that has nothing to do with this. Tell you never what I just said. Okay, this is just to give you an example of what kind of math we did before that's going to apply to this. So check this out. We did stuff like this. 2x over 5 plus x over 10 equals 1. Remember these? To get rid of the denominators, we needed to multiply times the LCD, which is what? 10. And we multiplied only times the numerator and the whole number. Remember that? Why? Because we can write this over 1, and this became 20x over 5 plus 10x over 10 equals 10. And what did we notice? And I asked you guys, remember when we got to these, what didn't change? The denominator. Notice that the denominator stayed the same. Remember that? So you remember what I just said? Okay, so now, does everybody understand this process? We multiply times the LCD, only the numerators. From there, we get to here because the denominators are the same, and then we can simplify. 20 divided by 5 gives us 4x. 10x divided by 10, that gives us x, and we're left with 10. Does everybody see that? Giant 1 right here. This was 4 times 5, the giant 1 right there. Okay, so now that we have the process, let me get started with this. You're just paying attention. Here it goes. So, here we do not have numbers though. So if I look at them, here's x and here's x squared. I can factor this one out and ask you, what does this one need that this one has? Another x, so I multiply times. So now, does this look the same as this? So my LCM is what? X to the second power. Are we there? That means I'm going to multiply the entire equation by x squared, but only the what? The numerators and the whole number. So check this out. What do I write? 4x squared over x minus 3x squared over x squared equals 1x squared. Copy that, please. So, let's look at this fraction. 4x squared. Doesn't this x cancel or divide out an x from here? And we're left with 4x minus. Do you see the giant 1 right here? And we're left with 3 equals x squared. Are we there so far? Okay, so now we need to get all variables to one side. So do you want me to get the x squared over here or these over here? Okay, so the x squared over here, so I subtract x squared, subtract x squared. This becomes 0 equals negative x squared plus 4x minus 3. And you're saying, wait a minute, Mr. Q, that looks familiar. Power Rangers, right? Bam! But don't forget about the GCF. What's our GCF? Negative 1, because of the leading coefficient is a negative. So we're left with x squared minus 4x plus 3. Now we can use our Power Rangers. So what factors of 3 add up to negative 4. Negative 3 times negative 1, so this becomes, this one is x, and one of them is negative 3, the other one is negative 1. Bring down the BFF, don't forget them. And now that we have all these, we set each one equal to 0. Negative 1 equal to 0, x minus 3 equal to 0, x minus 1 equal to 0. We there so far? And now we solve. Is this true right here? No. This one, plus 3, x equals 3. This one, plus 1, x equals 1. And we're done. That's it. Okay? Copy this next example down, please. Copy this next one down. 2B. Here we go. This will be your ticket up. Here we go. 2 over x plus 1, 3 over x, and 5 over 2x. This is the last one. Here you go. I'm going to go a little bit fast, so if you want to just pay attention for this. Here it goes. And then I'll have you copy. Here we go. You're wasting time. Here we go. We need to multiply times the LCD. So, let me ask you this. Guys, focus. What does this one need that this one has? 2. What does this one need that this one has? 2x. Right? And what do these need that this has? X plus 1. X plus 1. Remember, we're multiplying, we're not adding. So our LCD is 2x times x plus 1. Are we there? Okay, so now, I'm going to erase this so you can see it. So check this out. I'm going to multiply everything times the LCD. What do we have in the numerator here? 2 times what? 2x times x plus 1 over, what stays the same? X plus 1 plus, what goes here? 3 times 2x times x plus 1 over what? X equals, what's here? 5 times 2x times x plus 1 over 2x. Are we there so far? And when we simplify, do you see the giant 1 here? We're left with 4x plus, you see the giant 1 with the x's. What is 3 times 2? 6 times x plus 1 equals 5 times x plus 1. Do we know what to do from there? Yeah. All we have to do is distribute, solve, and go. So here we go. For homework, page 676, numbers 1 through 23 odd, and pages EP4 through EP21. Have a good break, everyone. Enjoy your homework. See you guys in a couple of weeks.